Hello, my name is Mary Jo Fender and this is Math for Middle School. Today what we're going to be talking about is solving equations with one variable. You'll need some paper and pencil to follow along. Okay, let's get ready to learn. When we talk about solving equations in one variable, we're talking about equations that are mathematical statements that consist of an equal symbol between two expressions of the same value. I have four different equations here. The two on the right are actually complete equations, meaning they don't have any variables. The ones on the right actually contain variables, and those are going to be the ones like we're going to be working with today. But I want you to notice something about the ones on the left. Both of these equations, if we go ahead and solve or simplify the side of the equation that we can work, we actually notice that both of sides of the equations are equal. So 3 plus negative 7 is negative 4, and negative 4 is equal to negative 4, so we call that a true statement. And notice we have minus a negative. Remember from our last conversation that is the same as saying plus a positive number. And negative 2 plus 8 is going to be 6. So 6 does equal 6, so that is also true. So if you come over and look on the right, we have some missing terms. These are called variables. We represent them with the letter X or N most normally. And this is the type of equation that we're going to be working with. Let's take a look at some vocabulary before we get too far. A variable is going to be a term that represents an unknown quantity. Like I said earlier, X and N are going to be your most common. But sometimes in story problems, we're going to write letters that are the beginning letter of the word. Makes it a lot easier for us to remember what that missing variable actually represents. A constant is a term that remains the same. Those are going to be the numbers that don't have a variable attached. They are always going to be 7. They're always going to be negative 2. Those are the two examples that I gave you. Inverse operation are mathematical operations that are reverse of each other or undo each other, such as addition and subtraction or multiplication or division. As you get later on in the school year, you're going to be talking about square roots and powers. Those are going to be opposite or inverse operations. Think of an equation like a teeter-totter. We've all been on teeter-totters in the playground. There's a happy medium where both sides are going to be equal. And that's where we want to keep our equations. If we remove a number from one side, our equation is going to be lopsided, and one side's going to be higher than the other, and it's going to be out of what we call equality. And we need to make sure that all of our equations are in equality at all times. Remember to keep both sides of them balanced. We must do the same thing. So let's take a look at our first one. X plus 8 equals 15. You can already probably think in your head, okay, I already know a number. What plus 8 is going to be 15? Well, that's great, and you can already say that, but sometimes we want to practice our actual steps or show our algebraic thinking. So if we think about, okay, what plus 8 is going to be 15, we're going to subtract 8 from both sides. So when we do that, that creates what we know as a zero pair. And we're going to do the same thing on the other side. So X is going to be equal to 7. Hope that was a number you were thinking of because that was easy. Okay, let's try another one. X minus 3 is going to be 8. I hope you already have a number in your head. Oh, well, that's right. I'm just going to add 3 to 8, and that's going to give me my missing number. Absolutely. And to show that algebraically, we're going to add 3 to both sides. We're going to add 3 to both sides. Remember, we got to keep that equation in balance. When we're thinking about, okay, what can I do? I'm just going to add 8 or add 3 to the other side where 8 is. We can do that. That's perfectly fine, but our equation is out of balance, so we need to think about that equality part. So that's going to be 11 So x is going to equal 11. Let's do one with multiplication. What's the opposite of multiplication? Awesome, it's division. So what we're going to do is we're going to use a fraction bar to represent our division. And so notice our x, it's -5 times x is equal to 35. Well, remember, we're going to undo it. So instead of multiplying times -5, we're going to divide by -5. So we're going to divide by -5, divide by -5. Okay, x is going to equal, yeah, I heard it, -7. Good job. Let's try another one. What's the opposite of division? Right, multiplication. Remember that fraction bar right there? That fraction bar means division. So the opposite of that is going to be multiplication. So I can just come down here and say times 12, or probably the way your math teachers are going to be showing it to you, they're going to stick a dot right here and say times 12, and they're going to do the same thing on the other side. So what's 3 times 12? Awesome, that's 36. So x is going to be 36. So let's talk about when we work with multiple operation equations. So remember, we're going to do the reverse of order of operations for these problems. So order of operation is going to be parentheses. Probably about 6th grade, 7th grade, parentheses really kind of goes out of style because we're having other symbols come in and they represent our grouping symbols. So parentheses, grouping symbols, then we're going to do exponents, then it's multiplication or division working left to right, and then it's addition or subtraction working left to right. But remember, we're undoing these, we're working them in reverse, so we're going to go in reverse. So the first thing we're going to undo is going to be our addition or subtraction. Then we're going to be doing our multiplication, and then we're going to be doing our exponents. Now I'm going to not really list parentheses or grouping symbols because sometimes we're going to have to undo those grouping symbols to start off because we can't actually get to the addition, subtraction, or the other operations. So pay careful attention to the grouping symbols because we may have to do those first. So let's take a look. So if we have 3x minus 9 equals 15. So remember, in our order of operations, last thing we're going to do is addition or subtraction. So that's the first we're going to undo. So notice, and I'll put this in highlighter, is we're going to subtract 9. What's the opposite of subtracting 9? Yes, it's going to be adding 9. So we're going to add 9 to both sides. Remember, this is our teeter-totter. We're trying to keep it in balance. Whatever we do on one side, we have to do to the other, and that's called equality. It's actually called reflection of equality, but we'll get into that in Algebra 1 in high school. So then we're going to come down here. I always like to rewrite everything because that is going to keep my mind going, oh, the next step is, oh, the next step is. So take a break, rewrite your equation. Take some time to let your brain think about what's going on in the equation. It's better to be right than be fast. Accuracy is more important than speed. Speed you come up with as you practice, okay? So notice now we have 3x is equal to 24. Remember 3x, 3 times x, what's the inverse? Oh yeah, that's right, division. So we're going to divide by 3. Remember, whatever number we're multiplying by, we're going to do the reverse. We're going to divide by that same number. So this leaves my x all by itself. And 24 divided by 3 is, yep, that's 6. So our missing term x is actually 6. Let's take a look at another one. So 4x plus 6 is equal to 24. Give you a quick second. What's the last thing in order of operations? Ah, yeah, addition and subtraction. So notice here we have adding 6. What's its opposite? Yep, you got it, subtracting 6. So we're going to subtract 6 on this side. So now we have 4x is equal to, you got it, 16. So remember, we have multiplication here again. The inverse is, you got it, division. So we're going to divide by 4. We're going to divide by 4 on the opposite side. X is now equal to, you got it, 4. Good job. You really are getting the hang of this. Okay, let's throw in some division along with our subtraction. So notice I'm going to highlight for you our subtraction. Remember, this is the last thing in order of operations, which means it's the first thing to get undone. So what is the opposite of minus 3? You got it, plus 3. Remember, keep it in equality. We have to do plus 3 on the other side. Okay, so I'm going to go ahead and write that down as you think. What is 7 plus 3? Yep, it's 10. Now, notice this fraction bar. That fraction really means division. What's the inverse? You got it. Multiply. So we're going to multiply 5 on this side. So x is going to be equal to 50. That concludes our lesson for today. Let's take a quick review. To keep an equation in equality or balanced on both sides, we must treat both sides the same. Remember, a teeter-totter goes up, goes down. We want that great place in the middle where both sides are balanced. To isolate the variable, you're going to do the reverse, known as the inverse operation, until you come up with one side has your variable, the other side has one constant. Remember to keep working on solving equations. Practice makes accuracy, accuracy creates speed. Take time, work through the problems. If you need to create models using the teeter-totter method, go ahead, take the time to do that. It's been my pleasure having you in class today. My name is Mary Jo Fender, and I'll see you next week.